we want to add matrix equations to this sequence of events. We know we got linear systems, augmented matrix, reduced echelon form, general solution. And then we've just added stuff at the beginning and at the end. We've added vector equations and linear combinations to the beginning of that sequence. And we've added the parametric vector form at the end of that sequence of things. Now we're just going to add matrix equations to that sequence right at the beginning. The great thing is we've already done this. We just have to look at it from a certain point of view. So we are going to think of the columns of a matrix as a set of vectors. That's where this starts. The columns of a matrix. The columns of a matrix are a set of vectors. So I'm going to make A a matrix. Matrices are usually going to get capital letters as names. And I'm going to make this matrix. The matrix is going to be 1, negative 2, 3. Second column is 2, 0, negative 5. And the third column will be 0, 4, negative 11. So A is this 3 by 3 matrix. The columns of a matrix make a set of vectors. So one of the vectors in this set of vectors will be 1, negative 2, 3. The second vector will be the second column, 2, 0, negative 5. And the third vector can be the third column, 0, 4, negative 11. Usually, we might want to name the columns of a matrix, in which case we name them like vectors. So the standard names I would say A is the matrix. The first column is going to be A1, the second column will be A2, and the third column will be A3. I label them like vectors because I'm thinking of the columns of the matrix as a set of vectors. Notice that when I write A is this matrix, I use square brackets because it's a matrix, and I don't separate the columns of a matrix with commas. Square brackets for matrix. No commas between the columns. So in the previous example, we had a set of vectors. So we had that set of vectors. Curly brackets. Curly brackets for a set of vectors, commas between the vectors. Curly brackets for sets and commas between the vectors in sets. Square brackets for a matrix, no commas between the columns. This is just writing things properly. If you put commas in your matrix, you'll get the point across, but it will look weird. People say, oh, clearly this person is new. And that's totally okay. I'll just remind you. It's not like I'm going to take off points for that yet. But it would be like if you put commas in between the columns of your matrix, say matrix is A1, comma A2, comma A3. That would be like saying, oh, I need to pilot my car to the store. It's like, oh, no, that's not the words that go together. You get the idea across. People know what you're talking about. You're about to hop in a vehicle and drive to the store, but you would say drive, not pilot. I'm gonna drive my plane. That sounds weird. That's what it looks like when you put commas in between your columns of a matrix. It's also what it looks like if you don't put commas in between your vectors in a set. Like, oh man, this person is riding his car. So what we need to do is multiply a matrix by a vector. So if I want to multiply the vector ax, multiply a times x, I need however many columns I have in A, I need that many rows in x. And here's how we're going to think about multiplying a matrix by a vector. Remember that the columns of a matrix is a set of vectors. So if I multiply a matrix, this set of vectors by a column, I'm going to make a linear combination of the columns of A using the coordinates in x. I should say entries, using the entries in x as weights. So this is going to be equal to x1 times the first column plus x2 times the second column plus x3 times the third column. So AX is a linear combination of the columns of A using the entries in X as weights. So AX, oh, that's too weird. When I say multiply AX, make a linear combination of the columns of A using the entries in X as weights. Should be a -5, yes. A -2. So AX is a linear combination of the columns of A using the entries in X as weights. The reason that we want to think of it this way and not just the mechanical row column multiplication that you might be familiar with is that we want to put this in terms of things and we want this to fit in the way we're already thinking about linear algebra. We want to think in terms of sets of vectors. We want to think in terms of vector equations.
Can I ask a question? So in AX, the X in here, it's vector.
Yes.
But then when you break it down to 3 different X's, they are gonna be just variable?
Yeah, those are just scalars. So x1, x2, and x3 are the scalars that make up the vector x.
Okay, thank you.
So x with the bar over it is the vector. It has 3 components, x1, x2, and x3. And the x1, x2, and x3 are all just scalars. So if I said something like, let B equal the vector, I don't know, let me come up with something totally at random. If B is a vector, B is the vector -3, -2, 13, and A is this matrix, I could ask a question, is AX equal B consistent? That's equivalent to saying, is B a linear combination of the columns of A? And just like before, if so, then how? And that would be the general solution or parametric vector form. So this matrix equation business, that's just another way that we can summarize the same question. Is one vector a linear combination of the others? Any questions? One last thing that I want to bring up is, since we're going into the long weekend, because this class has long weekends, is if we go back to, actually we'll go back 2 pages. So here we had V1, V2, V3, and the vector B in the augmented matrix, and we got down to this reduced or echelon form. This told us that B was a linear combination of the vectors V1 and V2 and V3. Notice that V3 is not really necessary because V3 is a linear combination of V1 and V2. If I make this augmented matrix, I can see that V3 is a linear combination of V1 and V2. So if we're trying to be efficient, I don't really need V3. Anything I can build with V1, V2, and V3, I can build with V1 and V2. And so V3 is not efficient. I just need V1 and V2, but I definitely need both of them. So the next concept that we're going to look at, and I want to do inception and bring it up now so that when you read about it over the weekend, you don't just kind of panic. This is how we want to think about it. We're going to think about the concept of linear independence. In this case, V3 is not really necessary. Anything we can build with V1, V2, and V3, I can build with just V1 and V2, because if I need a V3 as a component, I just grab a -2 V1s plus 1 V2, and I've got myself a V3. So V3, the set V1, V2, V3 is not linearly independent. That set of 3 vectors is linearly dependent. But if I get rid of V3, now I have an efficient set. I just need V1 and V2. That set is linearly independent. Notice that everything's a pivot. Any questions? So these are the kinds of things that we're going to look for when we're looking at the reduced or echelon form. We want to find out everything that the reduced or echelon form tells us. Everything. I need the Gary Oldman gif. Everything. Any questions? Comments? Yes, we need all these different representations. More representation is better. Hey, that fits in a lot of situations. Sometimes it's going to be efficient to describe things one way or the other. But it all comes down to making linear combinations of vectors. It's going to be fun. If we get this sorted out now in chapter 1, then when we get to chapter 4 is going to be like, hey, didn't we do this before? And I'll be like, oh yeah, chapter 4 is just chapter 1, just more generalized. All right. That's going to do it for today. That's going to do it for this week. The assignments that we've actually covered stuff on are 1.1, 2, 3, and 4. Those are the 4 homework assignments you should be working on. There are 4 quizzes available for you to start working on. Remember, if you submit a quiz and I take off points, that's your cue to redo the problems and submit the quiz again. And then if I take off points again, that's your cue to redo the quiz and submit the quiz again until you're happy with the amount of points that you have. There should be multiple attempts for all the quizzes. I'll double check. And if you can't do a second attempt, let me know. All right. that's going to do it for today. That's going to do it for this week. Everybody have a nice weekend. I'll answer homework questions on Monday. Thanks for playing.